Why don't 10 agents code 10 times faster? It's the same reason that 10 cooks don't make soup 10 times faster. You can break subcomponents of the soup making out. Like, for example, you could have a prep chef that cooks the onions and gets all the ingredients together. And then you also could have another chef that works on boiling the water, but you can't divide it evenly, even though you'll get some speed up by adding more people to the task. That's why if you look at the Amdahl's law, it's a principle that even though you have the ability to share work to cores, for example, there still is a sequential component of the work that allows for diminishing returns. What this really means is that there's a logarithmic relationship. So after enough cores are added, that sequential work becomes very significant, and adding more cores does almost nothing to actually making the real world task faster. And so the sequential work is what is going to be the hard ceiling. If you add more workers, there's going to be a diminishing return, and even infinite workers are not going to be able to overcome a sleep, for example, in the code. And if we look at the traditional computing example, would be IO operations, would be sequential bottlenecks, disk reads like network calls, database locks. And if the CPU is waiting for this, it's not able to speed things up. So it's not the case that you have 16 cores and it's going to be 16 times faster in the real world. Now, if we take this concept and we apply it to agentic coding reality, it's a good paradigm to look at things. I first heard about this from Princeton and some of their research around AI agents. And I'm also going to talk about it from my own perspective, and that agentic coding reality is that the human review becomes the new IO bottleneck. Also, you have to deploy it to production. So who is actually going to deploy this sequential task? You also have to have trust building. So you can't parallelize things with trust building, like do you actually believe that the code is the kind of code you want into your production code base? And then you have the context as well. There's human cognitive limits if you have hundreds of thousands of lines of code. And so if you look at the numbers, maybe 2 agents could give you a 1.3 speed up, 10 agents, maybe it's a 1.8, 100 would be like a 1.96. So really what we're thinking about is potentially the theoretical max could be 2 times faster. So does it really mean that AI is going to automate jobs, or is that it's more like coding assistants are like Amdahl's law? And I think this is a pretty good way to think about what is happening with coding assistants. Is it's a minimal lift. If you do enough, there's potentially maybe a theoretical 2x speed, but there are real bottlenecks. Code review requires humans. Testing, right? That's a very sequential operation. The deployment as well is it very sequential. And then you have the trust. If you're deploying bad code into production, deleting customer data, causing revenue problems, there's going to be a real bottleneck there as well. So I think what we'll see is that Amdahl's law or some variant of it will emerge in the space of agentic coding. We see this from some of the research at Princeton, and we see, in fact, that more agents don't have a proportional speed up. Humans become the new IO. And so it's just a different way of looking at the problem versus this magic, beanstalk that we can jump on and there's a kingdom we go to. There's a real world limit to the efficiency you get with agentic coding. And a lot of the efficiency is going to come down to how well organized and how thinking about the human in the loop as part of your process. All of those components will become what really makes your ability to use these agentic coding systems a reality or a fiction.